Hello, and welcome to 7.4 Notes. If you hear my daughter babbling in the background, just ignore her. She's adorable. In these notes, we are going to be working through factoring trinomials. So a trinomial is it's a three-term polynomial. So a trinomial is a three-term polynomial. And we've been working with polynomials. We've been adding them, subtracting them, multiplying them. And today we are going to learn what to do in how to factor them. So factoring, it's not quite dividing, but it's like it's taking a trinomial and it's reverse multiplying. So even though it's not dividing, we think about dividing being the opposite, it's kind of reverse multiplying. And I'm going to give you an example of maybe what reverse multiplying could look like right here. And this might be an oversimplified example, but hang with me and it might help later on. If I was given the number 12, I could reverse multiply. I could break that number down. I could factor it, right? I could break it into its factors of, say, 6 times 2. And then I could further factor 6 down into 3 times 2. So 3, 2, and 2, we use the 6 up to make the 3 and 2, are all factors of 12. These are the basic numbers that would multiply up to make this main number that we have. We are going to be doing something similar with trinomials. So remember, with multiplying, x plus 2 times, 3x plus 4. Actually, let me keep it a little bit more simple for this example, times x minus 5. So these are two binomials, and they multiply up however way you like to do it, the box or the double distribution or the expanded. So we do x times x to get x squared, and x times negative 5 to get negative 5x. And then we could do 2 times x to get positive 2x, and 2 times negative 5 to get negative 10. And then we would combine our like terms. In fact, I goofed on this one, but I usually stack them, right? I usually write them like this. But even if I write them out like this, it's okay. We combine our like terms, and that makes negative 3x. And then I still have my x squared minus 10, and this would be my answer when I multiply them up. Well, today we're going to learn how to take x squared minus 3x minus 10, and if we were only given this, we are going to learn how to take that and turn it in to this. So we're going to learn how to take this, and we're going to learn how to take a trinomial and turn it into the two groups that multiplied up to make that trinomial. So we're going to be working with three-term polynomials, and there are two kinds that we're going to be working with. Now in this video, and 7.4 in general, we are only going to be working with no leading coefficient. 7.5 we will cover what to do with a leading coefficient, but I want you to see them both. They are going to be written in what's called standard form. So I'm going to bring your attention here. Standard form is when we have three terms, and we have like our highest x value, our medium, and then our small. So it's written in descending order, and A, B, and C all represent numbers. So for no leading coefficient is really a coefficient of 1. So I'm going to just make a little side note here. It's really a leading coefficient, and that's just our number that is next to our variable, and leading being our first number. So a leading coefficient of 1. And we know with ones we don't write that. So if we look at our example here, for standard form, this is always going to be 1 when we have no leading coefficient. So look at our example. Let's compare this to our example. This is 1x squared, but we don't really write that. So it's just x squared. And then we're going to have a number next to x, and then we're going to have a constant term, or a c term at the end there, okay? So when we have a 3-term polynomial like this, which we call a trinomial, there are some patterns that allow us to identify what multiplied to create those 3 terms. And if there's no pattern, then it's not factorable. So think about, like, again, going back to 12, there are some patterns, right? We could divide, but we know we can divide by 2 because it's an even number. So that helps us break it down, and then we can break this down further. So there are patterns that we're going to learn to look for and follow that will help us be able to break these down. So we have our A value, our B value, and our C value. And I'm going to talk to you a little bit about how we find those patterns using something called the X factor. And we're going to practice completing the X factor in a moment. But this is really going to be some of the work that we have to do in order to be successful at these and find the numbers in the pattern. And once you've found the numbers, you're going to discover that it's actually much, much simpler than it looks. So hang with me. I think of these as number puzzles. These factoring for me is one of my favorite things to teach because they're like number puzzles. But it takes a little bit to learn the rules. So in our X factor, we are always going to do our first term times our last term. So A times C, and that value gets written on the top here. When we have no leading coefficient, it's 1 times 6, or it's going to be 1 times, whenever there's no leading coefficient, it's 1 times whatever number you have. So this is always going to be 1 times that number. So it's always pretty much just going to end up being that number when there's no leading coefficient. If we compare that to down here, where there is a leading coefficient, there's a 2 here. So we would do 2 times 6 to create our X factor number. That would go right up on top there. But we'll tackle that next time. Okay, so no leading coefficient is like 1 times 6. So we're just going to take this 6, and it's going to get written in up top. I'll do it in red. And then we take our B term, which is our middle term here, B, and that gets written on the bottom. So 6 and 5. And whatever the signs are, we're going to write the sign. So if I had a -6 on top, I would write -6. Or a -5 for the bottom, I would write -5. And that's how we begin to fill out the X factor. So let's jump down now and talk about how to complete the X factor. And you're going to have a Delta Math assignment that just has you practice finding the numbers. And I'm going to show you a couple tricks and things that I have available for you. But in order to complete the X factor, you must fill out the sides of the X with numbers that would multiply to make the top number and combine, that means add or subtract, to make the bottom number. So we know how to find the top and the bottom number. Those are given to us, right? Our top number comes from our A times C, and our bottom number is our B. It's our middle term. So let's practice here with this example. And I am going to fill out my X factor off to the side. And remember, it's our first times our last. Now, if I don't have a leading coefficient, if I don't see a number here, my brain goes, oh, I can just use this. I just used 24. And then our middle number goes in the bottom, 11. And you might see this along the way. Some people like to write in a little multiplication sign here. That means the number is multiplied to make 24, and a little addition sign here. They added to make 11. And so that's what we're looking for. What numbers would multiply to make 24 and combine to make 11? And there are several different ways that we can think of this. The first thing is you can do it with mental math. You can think, okay, 24, we always want to think about the factors of 24 first. We don't want to think about what adds up to 11. We want to think about the factors of 24. What numbers would make 24? Well, 1 times 24. That wouldn't work. 2 times 12. But that wouldn't work. 3 times 8. Oh, you know what? Mental math, as I'm going through the factors, 3 times 8. Let's check this. 3 times 8 does make 24. And 3 plus 8 does make 11. So these are the side numbers we were looking for. Now, I did that using mental math. I tried to kind of talk you through my process. But I want to show you another trick here, and that would be using a table. So if we use a table, off to the side, again, I'm going to put 24. I can kind of use that white line as my table. And on my table, I'm going to list what multiplies to make. So 1 and 24, 2 and 12, 3 and 8. If you find it, you could stop. If you just want to list them, 4 and 6, and 5 doesn't work, and then 6, if I'm back around to 6, that's going to make 4, so it's going to repeat its way. So I don't need to go any further once I hit that. So I can think, if I'm moving from left to right, 1 plus 24 is 25, and 24 minus 1 is 23. That doesn't work. 2 plus 12 is 14, and 12 minus 2 is 10. 3 plus 8 is 11. Oh, that's the number I'm looking for. So 3 and 8 are the combo that I needed. Okay. To give you even more of an opportunity, I'm going to jump down here, and I have created, and you're going to have to ask for this if you'd like it, but last year this was such a struggle for my students that I created this beautiful table that goes all the way up to 90. And so if you were to find 24 on this table, which here it is, 24, essentially I've listed out what are the factors, and I listed out what they make when you add them and what they make when you subtract them. So this would be your top number, and this is the side number that you're looking for. Or this is your bottom number here, 11. So 3 and 8. So if you would like to use that table, I just wanted to show it to you. You can ask and we can send it to you digitally, but it's time consuming to do that, and we would rather you kind of do the mental exercise first. Okay, so that's filling out the X factor. I'm going to do a couple more, and I'm not going to explain them near as much as I did that first one, but I just wanted to be very thorough on that. So we make an X. Our last number goes on top, 54. Our middle number goes on the bottom, 15. And I just use the last number because there's no leading coefficient. 1 times 54 is 54. Okay, so I'm thinking, what will multiply to make 54 and combine to make 15? So 54, I'm going to list some things. I know 1 times 54, 2, and that should be 27. 3 works. 3 goes into 5 once with 8 left, or with 2 left over, and so that's 18. 3 and 18. 4 doesn't work. 5 doesn't work. 6 and 9. 7 doesn't work. 8 doesn't work, and then we're back to 9. So now that I've listed these, again, if you can think of it off the top of your head, that's great. But I know 6 plus 9 makes 15. But 18 minus 3 also makes 15. So here's the deal. I guess I don't really need to write this on the side for now. Sometimes you'll get two numbers. What you need to be aware of is if I use 3 and 18, for example, one of them would have to be negative to make positive 15. I would have to have a negative 3 18 minus 3 makes 15. The problem is a negative 3 times a positive 18 would give us a negative 54. So 3 and 18 actually won't work for this example, but 6 plus 9 will. 6 plus 9 is 15. Okay, let's keep practicing here. All right. We have a negative 72 on top. We have a positive 1 on the bottom. Again, negative 72, it was 1 times 72. And then this is 1x, not 0x, so it's a 1 down there. And I'm thinking, what would multiply to make 72? I need to make a negative 72. So that means one of my numbers needs to be positive, one of them needs to be negative. So 1 and 72, 2 and 36, 3 and 24, 4 and 18, I believe. And so you can see how this is kind of time consuming to think through, but at the end of the day, and eventually what we want you to do is to be able to do this so quickly that you think of the numbers. So I'm looking at this and I already kind of know what the numbers are, but I want to list these out for you to see. So 4 and 18. Let's see, we would also have 5 wouldn't work, but 6 and 12 work. 7 doesn't work, 8 does, 8 times 9. Okay, and now I'm looking at which combination, so we'll look at them this way, which combination could make a 1? 8 and 9. 8 and 9 could make a 1 here. 8 and 9 could make a 1, and in order to make a 1, one of them needs to be negative, and it would need to be the 8. Because 9 minus 8 is positive 1. If I made the 9 negative, that would be 8 minus 9, and I would have a negative 1. So lots to think through and pay attention to. But there we have it. Those two multiply to make negative 72. All right, let's keep doing this because I think the more you see it, the better you'll get at it. So negative 12 on top. No leading coefficient. I don't need to multiply. Negative 4 on the bottom. I'm looking for what would multiply to make negative 12. I have 1 and 12, 2 and 6, 3 and 4. So which one would combine to make negative 4? Well, these wouldn't make negative 4. 2 minus 6, or 6 minus 2, actually the other way around, 2 minus 6, right? Oops. 2 minus 6. And then 3 and 4 would either make 7 if I add 7, or 1 if I subtract. So that's no good. These would make 8 if I add, 4 if I subtract. 4 is what I'm looking for. All right, last couple examples on just filling out the x factor. But I promise with no leading coefficient, this is the most work. This is the hardest part of no leading coefficient. Once we get our two numbers, we are cruising. So negative 40 goes on top, negative 6 on the bottom. I'm looking for what would multiply to make negative 40 and combine to make negative 6. I'm going to jump down to my chart here just to show you. So let's see, 40. Here's my 6, 4 and 10. So the chart's actually really nice. It took me a lot of work to create that. I should probably sell it to somebody. Okay, so that was, again, 4 and 10. And then we just have to figure out the signs. 4 times 10. And in order to get a negative 6 on the bottom, I'm going to need a negative 10 there. Your big number is always going to have the same sign as your bottom number. Just a life hack there. All right, and our last one, 10 on top, negative 11 on the bottom. These ones trip students up all the time because they think, okay, so 10 is 2 and 5, right? And they go, well, 2 and 5 doesn't work, so this doesn't work. what we need to remember is that 1 times that number is also a factor. So 2 and 5 will make 7 or 3, but 1 and 10 does make 11. They could add together to make 11. So, I guess I used the wrong colors here, 1 and 10. And in order for them to, we always have to check our signs. To combine to make negative 11, they're going to have the same sign. So negative 1, negative 10. And we make sure that they multiply. Negative 1 times negative 10 is positive 10. Okay, take a breath. Filling out the X factor is the most difficult part. Once you've done that, you are straight chillin'. In fact, steps 1 through 5 here, for now we're going to actually factor to get our quantities that multiply. Steps 2, 3, and 4 are what I just taught you. So the only thing new here is going to be step 5. Step 1 you just covered in the last lesson, which is to look for a GCF. This is just general rules. We always want to look for a GCF and factor it out before we break everything down. So and that's greatest common factor for those who aren't tracking. So, okay, fill out the X factor. And I'm going to do this quickly in my head. But I've given you strategies. I've shown you. So 20 and 9. And that's going to be 4 times 5. Okay, so now that we've practiced filling out the X factor, here is the last step that you need for no leading coefficient. Now, if there's no leading coefficient, there's no extra work. Next time we're going to learn when there is a leading coefficient, there is extra work. But for no leading coefficient, all we have to do is say x plus 4 times x plus 5. These are the two groups, the two quantities that multiplied to make this. And if you don't believe me, I'll show you just on this one. I don't want to spend more time on this than I have to. But x times x, x times 5, we have 4 times x, and we have 4 times 5. And when we put these together, x squared plus 9x plus 20. So I was able to multiply those back up to make my original. So when you find these numbers, you find the numbers that multiply to make 20 and combine, right, add or subtract to make 9. Those are the numbers from your group. So let's see it again. You have a negative 12. You have a negative 1. That was a negative 1k. So what would multiply to make negative 12 and combine to make a negative 1? It would be a negative 4 and a positive 3. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So now we have those groups. The last step is to use them to make our quantity. So we're saying k minus 4 times k plus 3. And because of the multiplicative, the commutative property, if you write your answer like this, k plus 3 times k minus 4, that is also correct. 3 times 4 is the same thing as 4 times 3. So one group times the other is the same. All right. Here's kind of a larger one. We have 55 and 16. But that doesn't throw you off too much. You probably figured out it was just 5 times 11. Those are the two numbers we use. So we're saying v plus 5, v plus 11. And if you needed to make a table, you could make your table. If you needed to use the chart, you could use the chart. See how quickly this goes after you fill out your x factor. So 20 and 12, that's going to be 2 times 10. And now that I have my side numbers, I'm saying r plus 2, r plus 10. All right, these last two examples, you're probably not going to see this today on your own practice, but I wanted to show it to you anyways, and that is that our first line of defense is to always look for a greatest common factor first. So in this one, we have a greatest common factor of 2. That means that all three of my numbers here could be divided by 2. I could divide a 2 out, and that would leave me with n squared minus 2n minus 3. So I took this whole thing and I said, if I were to divide a 2, it would leave me with this group here. Now I'm going to fill my x factor out just using this group. So I'm going to use a negative 3 and a negative 2, and that is going to be negative 3 times positive 1. And then in our answer, we have to leave the number, or the what we factored out, so 2 times n minus 3, n plus 1. Good grief. So, same thing. I can factor out a 3 from all of these. And I can also factor out a v, because all three of these have a v that I could divide. So if I divide out a 3v, that would leave me with v squared minus 15v. I'm sorry, not 15. And there's a lot of moving pieces. Minus 5v, because 15 divided by 3, and then plus 6, because 18 divided by 3. And now this is what I would use for my x factor. So I have an x factor, 6 and negative 5, and that's going to be negative 3 times negative 2. So in our final answer, which I'll do in purple, we would get 3v times v minus 3 times v minus, like that. Okay, so hopefully that makes sense. The actual factoring goes really fast. Getting the numbers goes really fast once we learn how to complete that x factor.